The topics covered in this introduction to OpenNMS include its definition and capabilities, how it is distributed and supported, system requirements and architecture, and a look at the OpenNMS GitHub site. Hello, and welcome to the OpenNMS 101 Again playlist. This 2024 playlist is meant to be an update to the original 2017 OpenNMS 101 playlist hosted by Tarus, Balog, and the OpenNMS group. My name is Bob Vera, and, along with a myriad of other duties, I was an OpenNMS technical admin for 8 years with a government contractor before retiring at the start of 2024. What is OpenNMS? That question can be answered by going to the OpenNMS webpage, www.opennms.com, and scrolling down just a bit. OpenNMS is an open-source, comprehensive network monitoring platform that is scalable and extensible, with a number of support options available. Take a look at some of the links available on the OpenNMS homepage, beginning with the FAQ and focusing on general topics. If you are wondering what OpenNMS can monitor, take a look at this list. This list is not exhaustive. The key line is, if your device is not on this list, there may be some community-contributed configurations available, or you can easily create your own. This will be demonstrated in short order. Moving on to the OpenNMS distributions, by selecting Distributions from the Learn dropdown, we see that there are two OpenNMS distributions, Horizon and Meridian. Both distributions are covered under the Alfaro General Public License. A link is provided so that you can better understand what this means. The OpenNMS community can make changes to Horizon via pull requests to the GitHub repository. Code improvements and supporting library updates are made to Horizon, and after a sufficient period of time and testing, those improvements and updates are integrated into Meridian. What goes into Meridian is controlled by the OpenNMS group. Both products are installed via Linux distribution packaging. Support for Horizon is generally through the OpenNMS community forum or OpenNMS chat. Meridian is supported via a subscription. Follow the support options link to get the pricing. On a personal note, I began using OpenNMS before the Horizon-Meridian split. At that time, support was purchased from the OpenNMS group. That support was more than sufficient. Business considerations caused my customer to opt for Meridian. From my point of view, there was no discernible difference between the two distributions other than a name and version change. Sometimes, being on the technical leading edge of a product has its pluses, and sometimes it has its minuses. The choice, as they say, is above my pay grade. If you are just starting out with OpenNMS, I would recommend Horizon. After a bit of time, measured in 1 or 2 years, it may be time to switch to Meridian. Now take a look at the OpenNMS documentation, which is found by clicking on Product Documentation under the Docs dropdown. Note that the left-hand column has current and legacy documentation for various OpenNMS components, including Horizon and Meridian. Click on the latest version of Horizon. This is the latest Horizon documentation. Before continuing, it should be pointed out that this module was created with Horizon 32, but that OpenNMS has since released a new version of Horizon, version 33. This particular module will continue to use Horizon 32, but subsequent modules will use Horizon 33. A breakdown of Horizon's topics is in the left-hand column: release notes, deployment, operation, and so on. Scroll down a bit and note the sample full-stack Horizon implementation. This playlist is concerned with the OpenNMS core, the PostgreSQL database, and the built-in metrics data store in place of Apache Cassandra. Apache Cassandra clusters can be used to store time series performance data for large network environments. Smaller environments can use OpenNMS's built-in storage using RRDTool or JRobin to store performance data locally. OpenNMS does provide a decent graphical view of the collected metric data, but Grafana provides a higher level of user interface. Minions enable Horizon to monitor devices and services in locations that it otherwise could not reach, for example, behind a firewall. Sentinel provides scalability for data processing of flows and streaming telemetry received by one or more minions. It also provides thresholding for streaming telemetry if you are using OpenNMS newts. Jump to OpenNMS Horizon under Deployment. This is the basic Horizon deployment architecture diagram. OpenNMS monitors devices and their interfaces. This is usually done via SNMP. Monitoring, which includes polling and metric data collection, is configurable. Provisioning is the process of adding devices to OpenNMS. Once a device is provisioned, OpenNMS uses detectors to determine what services are available and begins the process of polling and collecting per configuration. OpenNMS can process SNMP traps, syslog messages, telemetry, and properly formatted XML data. Notifications, for example using email or messaging, alarms, and general forwarding are possible with OpenNMS. OpenNMS can be accessed via the web interface or REST calls. OpenNMS is highly configurable. Logging includes alarms, events, collection, polling, discovery, web activities, and more. There are 5 logging levels: error, warn, debug, info, and trace. Logging is configurable. Node, device information, event and alarm information are kept in the PostgreSQL database. The round-robin database keeps the performance data. Looking at what's new under the release notes, note that OpenNMS runs with JDK 11 or 17 and will run with PostgreSQL versions 10 through 15. Look at the minimum system requirements. The configuration used in this playlist will be covered in the installation module. In general, your intended workload, the number of nodes, the number of monitored metrics per node, flows, events, and data retention requirements affects your system requirements. You can install OpenNMS on a number of different Linux distributions. Keep in mind that OS support may be necessary for a production environment. There are only 4 required components under compatibility: JDK, PostgreSQL, RRDTool, and a browser. During the install process, OpenNMS will look for a compatible JDK. OpenNMS usually stays compatible with the latest version of PostgreSQL. The RRDTool package is usually installed alongside OpenNMS. I have been able to access OpenNMS using Firefox, Chrome, and Edge. Let's talk about the free support that is available through the Horizon community. Select Community Horizon. You can download Horizon from here. For now, scroll down a bit on the resulting page and click on Community Support. This will take you to the OpenNMS Discourse webpage. This is a good starting point if you need help. Feel free to sign up and ask questions as necessary. You can also take a look at OpenNMS Chat. Click on the link on the left or go to chat.opennms.com. Feel free to sign up and ask questions as necessary. Both OpenNMS Discourse and Chat are active. Returning to the community webpage, take some time to look at the OpenNMS source code repository on GitHub. Delving into the repository at this point is out of scope, but its existence and its use in low-level debugging should be noted. Up next, Module 01, Installing OpenNMS.